You ever wonder how an AI can read a super blurry license plate or, understand what you're saying in a really loud cafe? Well, it's not magic. A huge part of the secret, and this is pretty wild, is that it learns from data that was never even real in the first place. Yeah, you heard that right. Today, we're going to dive into this amazing world of artificial data synthesis. It's a really clever technique that's behind some of the smartest AI out there. All right, so let's just start with the big question, right? Why is the AI we have today so powerful? I mean, we're talking about the stuff on our phones, the assistants we talk to, even the AI that's tackling huge scientific problems. What makes it so incredibly good at what it does? The answer? Well, it's probably not what you're thinking. And here it is. The answer, most of the time, isn't some crazy complicated algorithm nobody understands. Nope. The real secret sauce is data. And not just a little bit of data. We're talking about a massive, massive amount of it. Think of it like this. The more examples you show an AI, just like a student, the smarter and better it's going to get. It's that simple. Okay, but that just brings up another huge question. Where does all this data come from? I mean, sure, it's easy to find a million pictures of cats on the internet, right? But what if you need to train an AI on something really rare? Like, say, images of a very specific rare medical condition, or the exact split second a critical machine part breaks. You can't just Google that. So where on earth do you get tons of data for things that almost never happen? And this is where it gets really, really cool. If you can't find the data you need, well, you just make it. So let's jump into our first section, making data from scratch. Okay, so let's nail down this key term for today, artificial data synthesis. It's actually pretty much what it sounds like. It's just the technique of creating brand new, totally artificial data from scratch. You do this when the real-world data is super hard to find or just doesn't exist in large enough quantities. It's a seriously elegant way to solve that whole not enough data problem. So how does this actually work? Let's take a classic example, teaching an AI to read text in pictures. Now, instead of spending forever trying to find millions of photos with text in them, we can start with some simple ingredients we literally all have on our computers. Yep, all those thousands of different fonts. And with those basic ingredients, we can start cooking up a nearly infinite supply of training data. You literally just take a character, like this letter C you see here, plop it onto some random background, maybe add a little blur, twist it a bit, and bam! Just like that, you've created a totally new, completely unique training image for the AI. And check this out. Look at the result. On the left, that's a real data from an actual photo. But on the right, that's all fake. It's all synthetically generated. And honestly, can you even tell the difference? It looks so realistic. This one trick gives us a practically unlimited stream of examples to train our AI on. It's a game changer. Okay, but what if you're not starting with nothing? What if you actually have a little bit of real data to work with? Well, that brings us to our second technique, multiplying existing data. Right, so instead of making data out of thin air, this next approach is all about amplifying what you already have. You take a small set of real examples, and you guessed it, you basically clone them and change them up to turn that small pile of data into a giant mountain of it. This image just shows the idea perfectly. Look at this. You start with one single, clean picture of the letter A. Then you just apply a bunch of little realistic tweaks. Stretch it a little here, skew it a little there, and out of that one image, you get 16 brand new unique examples. We literally just 16x'd our data from one single picture. How cool is that? And this trick isn't just for images. It works amazingly well for audio too. So imagine you have one perfectly clean audio recording. You can multiply it by just layering in different background noises. For example, let's say this is the original. Now what if we add the sound of a bad cell phone connection? Or put it in the middle of a noisy crowd? And what about some loud machinery? See, we just turned one clean sample into 4 new really useful training examples. Okay, this all sounds a little too good to be true, right? And, well, there is one really important catch. For any of this to actually work, you can't just add any random distortion. It has to be the right kind of distortion. And that brings us to section 3, the realism rule. This right here, this is the golden rule of making fake data. The quote says it all. The distortions you add have to be representative of what the AI will see in the real world. In other words, your fake noise has to match real noise. The imperfections you add need to be the same kind of imperfections the AI will actually have to deal with when it's doing its job. And this breakdown makes it super clear. On the left, you've got helpful noise. This is the good stuff, like warping a letter, adding background sounds, or blurring an image. Why is it helpful? Because these things actually happen in the real world. But on the right, you have unhelpful noise, like just adding a bunch of random staticky pixels. That's pretty much useless because when is an AI ever going to see that in real life? Probably never. And this image really drives the point home. Look at the top row. Those warped letters are meaningful distortions. They kind of mimic what a letter might look like if you're seeing it from a weird angle. That's something the AI needs to learn to handle. Now look at the bottom row. That's just static. It's random, meaningless noise. It doesn't teach the AI anything useful about what it'll see in the real world, so it doesn't help. All right, so we've talked a lot about the how, the actual techniques. But now let's switch gears and talk about the mindset this all leads to, which is something called the 10x data mindset. Okay, one really quick but super important sanity check. Before you go off and spend ages creating mountains of new data, you've got to make sure your AI can actually use it. In simple terms, is your AI model complex enough to learn all these new things? It's kind of like you don't want to try and pour a whole swimming pool's worth of water into a tiny cup. You got to make sure the container is big enough for what you're putting in it. Now this is the question that can change everything. When you're stuck trying to make an AI better, the first instinct is to tweak the code, right? But instead, try asking this. How much work would it really be to get 10 times as much data as we have right now? Just asking that question forces you to think differently. It makes you consider creative solutions, like all this data synthesis stuff we've been talking about. And you know what's wild? A lot of the time, the answer to that 10x data question is, you know what? It's actually way easier than I thought. It turns out that spending a few days being clever about generating new data can give you a much bigger boost in performance than spending months trying to fine-tune some complicated algorithm. So that brings us to the big takeaway here. This whole idea of artificial data synthesis isn't just some fancy trick for giant tech companies. It's a really powerful way of thinking about problem solving. So I want to leave you with a question to chew on. What problem in your work, in your life, could you maybe solve if you suddenly had 10 times more data? And even better, what if you were the one who could create it?